Hello, this is a video on neutralization reaction. Neutralization reactions, which I can't say, are actually double replacement reactions. The most common one is what they call acid-base reactions. But we need to be a little bit more specific because there's several different acid-base reactions that can exist. If you go long enough, i.e. take the AP Chemistry course, you'll see that there's all kinds of these things. So we'll be more definitive. What we'll talk about in this video in first year is a strong acid and a strong base neutralization reaction. And when that happens, and I'll give you an example, here's an example below. Sodium hydroxide, which is a strong base, plus HCl, which is a strong acid, it produces two things. It produces water and a salt. That salt should have a coefficient in front, and the coefficient is 1. So it is the neutralization reaction is one of the types of double replacement reactions. If you remember correctly, previous in the course, there are three products that must happen for a double replacement reaction to occur. At least one of the three must occur, which is form a solid, precipitation reactions, form a gas, or form water. This is the double replacement reaction that forms water. So what happens is, in a neutralization reaction, a strong acid and strong base, what you basically do is you produce water, because the strong acid, HCl, is a substance that produces H pluses, and the strong base produces OH minuses. And one H plus plus one OH minus gives you water. That's always the net ionic reaction of a strong acid and a strong base coming together. And when you neutralize, what that means is you are basically taking a substance that produces H pluses and adding it to a substance that produces OH minuses, making water. So both the H plus and the OH minus are no longer those substances. Now we have water. So when you do this in the lab, it's called a titration. So sometimes the calculations, you will see the word titrate, or the word neutralize. And what this meaning there is that exactly the same amount of H pluses in moles will be the number of OH minuses in moles. Not how many moles of the acid or base there is, but the moles of H plus and the moles of OH minus. So it is just like any other stoichiometric problem. You do the same exact steps. You find the balanced chemical reaction. The balanced chemical reaction is actually quite easy to figure out for a strong acid and a strong base. What you do is you look at, in this case, the base, and see how, in one of these things, how many OH minuses you get out. Since this is a 2, you're going to get 2 of them out. Well, you need to counterbalance exactly the same amount of H pluses. So in this guy right here, it only produces 1 H plus. So you need 2 sets of them. And then what you produce is an H plus and OH minus come together to form water. But you have 2 sets of them, so you form 2 waters. That's what the coefficient here is, and it's always water. Plus, and I guarantee you that what's left over, in this case, the cation of the base and the anion of the acid, will form an ionic compound with the right coefficients. As in, the coefficients here, over here, give you the subscripts there. So therefore, the coefficient in front of the salt. That's what a salt actually is. That's how you make a salt in an acid-base reaction. So that coefficient is always going to be 1. And that's the easiest way to balance acid-base reactions. So, so that's the first thing you need to get is a balanced chemical reaction. It looks like here what we're doing is we're figuring out the net ionic reaction, which we talked about before. Okay, so that's how we actually that's what actually a neutralization reaction is doing. It's actually taking every H plus and putting it with an OH minus. And that's what the word neutralize means. Because when an H plus, which comes from a solution that has a lot of H pluses in it, it's called an acid or acidic solution, and added to a solution that has a lot of OH minuses called a base or basic solution. When those H pluses and OH minuses come together, they form water, which isn't either one. So we say it's neutral, meaning a pH of 7, and it's a little bit more complicated than that, and we can talk about that in a different video. So that's what a neutralization does. Of course, you have further steps of stoichiometry, and I'll give you an example here. Here's an example. Now, it's basically the same as the video we watched in solution chemistry when we looked at solutions. Remembering that in the mole wheel with the introduction of solutions, we have molarity times volume will give us the moles. So it's the same exact thing. We will be given enough information to figure out the moles of the acid solute or the moles of the acid base, and then we try to find one of the two of the opposite, since it's an acid-base solution, since we both the substances are solutions. So here's a typical example of a neutralization reaction. So here I have sulfuric acid, H2SO4, and I have sodium hydroxide, NaOH. I need to balance it. Well, this guy, one of these guys produces 2 H pluses. One of these guys produces one Na1 pluses. So we need to form 2 waters and whatever else is left. Okay. So now what we need to do is we need to figure out what information we know. So a lot of times, I think I did it in the other one, a lot of times what I like to do is I like to write them. Here I just wrote the net ionic reaction, kind of get in the way. But I like to write the information. This is the same exact question, but this is by dimensional analysis. I like to do is I like to write the information right below, because then I can see what substance I know enough information about to get the moles. So it tells me that sodium hydroxide is 0.65 molarity, and there's 455 milliliters, and I have a 0.45 molarity sulfuric acid solution, and I want to know how many liters are going to be. So therefore, I know enough information for sodium hydroxide. So I'm going to first find the moles of sodium hydroxide, then find the moles of H2SO4, and once I find the moles of H2SO4, I can find the volume because I know the molarity. Okay, so why don't we just since we're here, why don't we just do a bidimensional analysis first? It doesn't really make a difference. So like I said, I know the sodium hydroxide information first. Now, since I have 2 volumes, I usually put, instead of just liters of solution, I write the liters of the substance solution, just so I don't mix them up. So these 2 things are together. But so the molarity is 0.65. I break up the big M into units because I cancel the units. And it's 455 milliliters. But milliliters cancel liters, so therefore I have to change liters into milliliters. Okay, so that's in the steps. That'll be step 2 if we consider step 1 balancing the chemical reaction. So now I have moles of NaOH, but I don't want moles of NaOH. I want moles of H2SO4. So here's my molar ratio. And at that point, I'm at step 3. I have moles of the things I'm looking for. Now the question is, what do you want to know about H2SO4? Because I already have the moles right here. So this whole calculation is moles. So I know the molarity, so I must be looking for the volume. So therefore, to get rid of the moles, I put the moles on the bottom and liters on the top, and the 0.45 comes to the bottom. So I do the math. I get 0.328 liters, which is 0.33 liters, because this is two significant figures, and that's two significant figures. Okay, so that's how you do it by dimensional analysis. No different than if it was just any solution. Okay, and again, you do the same. It would be the same thing up here, balancing reaction. Now in this case, you figured out that the NaOH is the moles we go first. So this is by equation. So moles is equal to molarity times volume. Got to change the volume into liters. Okay, on the side. I usually put it on this side, but I didn't. But that's all right. So you break up the big M into its units, and you get 0.295 moles of NaOH. I'm not using the substance next to liters because I've broken it up into subparts and I know what the substance is. So that's the second step, moles. Then I go from moles to what I know to what I'm looking for, okay, using the molar ratio. Now I'm going to find what I want, so here's my equation. I have to change it because I'm on volume. So it's moles over moles per liter, okay. And of course, the denominator over denominator is the numerator is equal to 0.326 liters, which is equal to 0.33 liters. So that's how you do a neutralization reaction and how you do any neutralization reaction. Okay, I hope this helps.